This is section 5.4, day 2, and today we're going to take our sum and difference formulas and then use them with tan this time. And tangents equations are just slightly more complicated, as it always is. So the tangent of a u plus v, so one angle plus another, you have those two separated on top, and then you actually flip the sign down here. So if you're a plus here, you're a plus minus, and you're multiplying them. And then if you subtract, you actually are subtraction on top and minus on the bottom. So you match on the top, you're different on the bottom. You match on the top, you're different on the bottom. And you do one addition or subtraction, then you do one multiplication. So just like tan always is, it's just a little more complicated, but we're going to use the same values around the circle, so none of that is going to change. So do tangent at 75, and 75, and the easiest two angles to use are 45 and 30. So I'm going to use this formula. I'm a tangent plus formula. So I'm going to do tangent 45 plus tan 30. And then on the bottom it's 1, and then opposite of whatever we did on top. And then it's these two multiplied. Oops, 30, not 3. And now we just need to use our unit circle to come up with all the values that we need. So tangent at 45, and hopefully you have these filled in on your circle. We filled them in chapter 4. So tangent at 45 is a 1. So you got 1 plus. Tangent at 30 degrees right here should be square root of 3 over 3. Over 1 minus, and then those two values are being multiplied. So now we just have a lot of algebra in order to clean this up. Essentially, we've done it. It's right here. But we're just going to clean it up because we got a lot of roots where they don't belong. So algebra from here on out. This was the pre-calc part, and now we're doing algebra. So on the bottom, if I'm multiplying by 1, I don't really need that. So we've got 1 plus root 3 over 3, and then 1 minus root 3 over 3. Those cannot cancel each other. Remember, you got to cancel an entire quantity in order for that to happen. And since we're not the same, I can't do that. Can't just take off my 1s and then take off my root 3s over 3s. So what I'm going to do is actually try and add these together. I've got two sets of fractions here, so I'm going to create common denominators. So I'm just going to put this over a 1 and this over a 1, so they've got a denominator, and then their common denominator would actually be a 3. So this is going to stay root 3 over 3 plus, and then if I made the bottom a 3, the top would also have to be a 3. On the bottom, something very similar is going to happen. You just have a subtraction sign instead. But in order to make this denominator a 3, you have to make the top a 3 as well. So that looks a bit more complicated than it was, but now the fact that we have common denominators means that I can put these together. So I can do my addition, I can do my subtraction, and kind of combine fractions to keep us going algebraically here. So on the top I've got 3 plus root 3 over 3, and then 3 minus root 3 over 3. Still can't cancel stuff. I can't cancel an entire quantity. But now we've got this complicated fraction over fraction-y looking thing. So I'm going to flip the bottom and bring it up. We've done that before when we've had stacked fractions. So this is the one I'm flipping so that they'll cancel, and 3 minus square root of 3, that whole quantity is canceling. And now I've got it down to just a one-level fraction. That's kind of nice, and we're multiplying, so 3's and 3's will cancel. So I end up with 3 plus root 3 over 3 minus root 3. And we are almost done. Problem now is you have a root in the bottom. I mean, technically we had a root in the bottom the entire time, but as we were trying to fix that, we still ended up with a root. So we're going to multiply by the conjugate. Slightly painful simplifying problem here. But once we get to the end, I'll show you what all tangent answers look like. Just like all sine and cosine answers were all some form of like square root of 6 and a square root of 2 over 4. Tangent has the exact same repetition once you get done simplifying. So you kind of know if you did your simplifying right if you get one of the answers that tangent always is. Excuse me. So now we're going to FOIL. On the bottom you've got conjugates, so they're going to cancel each other out. So I've got a 3 and a 3, which is 9. And then I've got a minus 3 root 3, a plus 3 root 3, so those cancel. And then you've got a minus root 9, a 3 times a 3, so that's root 9. On top we've got 3 times 3, which is 9. We've got a 3 root 3. Since it's all addition up there, we have to keep going. We need all of these middle terms. And then root 3 times root 3 is another root 9. excuse me, root 9 is just 3. So on the bottom you've got 9 minus 3, which is 6. On top you've got 9 and 3, which is 12. And you've got 3 root 3s and 3 more root 3s. It's kind of like saying I've got 3 oranges and 3 more oranges. So I've got a total of 6 oranges. You had 6 root 3s. Last step is everything is divisible by 6. So I'm going to cancel that, get a 2, and I'm going to cancel that and get a 1. So we ended up with 2 plus root 3. This is what every tangent answer looks like. It's some variation of 2's and root 3's, plus and minus for either of them, but there are 4 possible answers for you to get when doing a tangent. What I just showed you with tangent of 75 is by far the worst. This is the worst amount of algebra you have on a simplifying problem, and it is all because we picked to use a 30. So if you look on your unit circle, you actually have an easier tangent to use, and that would be a 60-degree angle. So anytime you can, and write this in your notes, anytime you can, choose a 60-degree instead of a 30-degree. So work your tail off to avoid these at all costs, because then you don't end up with this, which took all of that work to get it to here. If you use a 60-degree angle, you're going to skip right to this step. You'll jump right down to this one, you got a little foiling to do, and you're done. But anytime you have to use a 30-degree angle, you have to go through all of this pain first of common denominators, flipping complex fractions, stacked fractions, flipping them up. If you can use a 60, you skip right to this step, which is kind of a little less work. So let's do another one. Let's do tangent of 165. Again, not on your unit circle. You need to come up with 2 angles that get you to 165 degrees. And you want to use angles that are on your unit circle because those are the values we know. And if we want to stick to a 60 degree, we got to do a little guessing and checking until we find the match. That would be our 60 degree. So I could do 135 and 30. That would be an option. But again, that uses a 30-degree angle, and those are not very fun. They just involve a lot of that algebra foiling that we were doing up above. Excuse me. So 165, we got to get there, and I'd like to use a 60-degree angle, and that means any multiple of 60. So I could use 120 and 45. Those would actually get me also to 165, and then my 120 is really a 60-degree angle, so it'll be a little bit easier solving. So I'm going to do tangent of 120 and 45. And just a reminder, you can use any 2 angles you want as long as they get you to 165, and you will still get the same answer as me. So if you chose to do the 135 and the 30, you're going to get the same answer. You just have a little longer path with the simplifying, but they work the same every single time. So let's use our formula. I got tangent of 120 on top, plus a tangent of 45. On the bottom, we've got 1 minus tangent of 120 times tangent of 45. Using our unit circle, we'll just plug our values in. So at 120 degrees, our tangent should be negative square root of 3, and at 45, it will be a 1. So tangent at 120 is a negative square root of 3, and tangent at 45 is a 1. On the bottom, you have 1 minus a negative root 3 times a 1. So just watch your negatives here. It's a little easy to get those confused or to miss one. But timesing by 1 doesn't do anything, and then you've got a negative negative, so you've actually got 1 plus root 3. So looking at our example from above, we we're already at this step instead of having to go through all of that solely because we picked a 60-degree angle instead of a 30. So just a little bit of solving, algebraic solving to do simplifying. These cannot cancel. I cannot cancel a 1. You have to cancel the whole quantity or nothing at all. So I'm going to go ahead and multiply by the conjugate, which would be 1 minus root 3. And then we're going to FOIL on both top and bottom. Bottom's the easy one, because that's the conjugate, so everything should cancel. So I've got a 1, and then minus square root 3 times square root 3 is square root 9, which we talked about before. So I've got 1 minus 3 down there. On top, I've got negative square root of 3. And then I've got a positive square root of 9, which is 3. I've got 1 times 1. And I've got a 1 times a negative root 3. So So adding together like terms, I've got negative 2 on the bottom. We've got 4 right here. And I have a negative root 3, and I have another negative root 3, so that gives me negative 2 root 3s. And one last simplify step, everybody's divisible by negative 2. So 4 divided by negative 2 would be negative 2. And negative 2 divided by negative 2 would be 1. Just like the one up above, it's some combination of 2's and root 3's. Somebody might be negative or positive, but it is the same combination every single time when you do tangent. Last hint, again, try and avoid the 30s. They just make you have to do more algebra solving. Try and stick to the 60s as much as you can.